Next, I will explain how you can apply the first and second control techniques on the operation of single-phase and three-phase inverters. Let's start with the square wave control technique. The aim of the control technique is to regulate the inverter operation for generating a square wave AC output voltage waveform. To generate the positive half cycle of the output voltage, S1 in the half bridge inverter and S1 and S2 in the full bridge inverter must turn on from 0 until pi. Thus, we must apply this control pulse to the power switches. Meanwhile, to generate the negative half cycle of the output voltage, we must apply the following control pulse to turn on S2 in the half bridge and S3 and S4 in the full bridge. According to the graph, the conduction angle of each power switch is fixed at 180 degrees. Next, by using the quasi-square wave control technique, the inverter will generate a quasi-square wave output voltage waveform. To achieve the aim of the control technique, we must apply the following control pulses to the respective power switches. Based on the waveform, the conduction angle of each power switch is now 120 degrees. Unlike the single-phase control techniques, the aim of the three-phase control techniques focuses on the conduction angle value. In the 120 degrees conduction mode control technique, each power switch must turn on for 120 degrees only. As we can see, each power switch is controlled using a control pulse injected at a different time interval. The control pulse for S2 is displaced by 60 degrees from the S1's control signal. Similarly, the S3 control pulse is displaced by 60 degrees from the control pulse of S2. This control pattern is consistent throughout the inverter operation. Now, let's see which power switches will turn on in between 0 to 60 degrees. Based on the control pulses, we can see S1 and S6 will turn on. Meanwhile, in between 60 degrees to 120 degrees, switch S1 and S2 will turn on. You can try to complete the switching sequence for this control technique later. Next, let's look at the 180 degrees conduction mode control technique. According to the graph, we can see the control pattern is similar to 120 degrees conduction mode, except for the width of the control pulses. This time, the width of each control pulse is 180 degrees. Hence, the conduction angle of each power switch is also 180 degrees.